Hey, hello everyone. Fabio Caversan here. As Spencer mentioned, I'm living in North America now for 2 years. I'm here on a cold, rainy day in Michigan, and I want to talk to you guys a little bit about AI landscape and how we are positioning Sophie in this landscape. And I want to start by saying that it's been really an amazing experience for me to work with AI, with artificial intelligence, for the last 2 decades, to be honest. And during those 20 years, I've seen transformations and revolutions, and the field never stops to amaze me. So, and I know that like every field that have people with so much passion, uh, uh, dedicated people, AI, we have all the tribes, philosophical schools, teams. So AI is like one of those topics that you should avoid in conversations at a bar or something like that, like football or politics or things like that. It can get heated so fast. There was a time, and that even overflowed already to different areas, not only science or mathematics or engineering, even entertainment, right? There was a time that I could proudly say that I had watched all the movies or shows that we had out there related to AI. Well, nowadays I just can't keep up with everything. So I talking about shows and science fiction and everything. That's how I wanted to drive this talk today. So I want to start on the high level, philosophical or even science fiction side, and then I want to go slowly, narrowing to arrive at what we are doing with Sophie and how we align our strategy to keep this product improving over time in that landscape. Um, like Spencer said, that's our always our goal. This continuous evolution and improvement. And luckily enough, we have more than enough room to grow and to evolve this product. So uh, let me start by talking about AGI and ANI. One of them is artificial generic intelligence, and the other one is artificial narrow intelligence. I don't want to even go in ASI, that is artificial super intelligence. That's too much science fiction for us today. So, artificial narrow intelligence is what we have nowadays. We have amazing achievements, amazing systems, and Sophie is one example of ANI. So it's an AI system built for a certain domain, and although all AI systems are supposed to have some flexibility and be able to handle unexpected situations, um, there is a limit to how far this can a specific AI system go within a certain scope. Now, artificial generic intelligence is a different thing. It's a system that will be capable to learn a completely new skill that it hasn't been trained to do. So imagine that you have the amazing systems that beat the major chess players, like uh, 3D Fritz, Deep Blue, and etc. And then you put those systems to drive a car. Naturally, it will struggle a little bit in the beginning, but after a certain period of time, will drive the car as flawlessly as it has played with the top champions of chess. So that's the thing, and we are not close to that nowadays. And uh, when I say we're not close, I say we're not close in terms of technology, science, and state of the art AI techniques. Now, we might be very close in terms of time. Maybe 2 years from now, we will have something that would achieve something closer to AGI. Now, there are different, now the tribes start, the schools or the philosophical schools of thought. So you have people saying, no, we will achieve AGI, just a matter of time, we're getting there. On the opposite side, you have, no, AGI is impossible, we'll never get there. And then you have people in between, right? All the scales saying, hey, okay, we might not get to AGI, but we are not even close. Maybe we can do more 3 or 4 steps towards AGI. And if we do that, well, we will have some new amazing stuff out there in the world to help us on our houses, workplaces, and etc. Now, regardless of your school or philosophical thinking, there's one thing that the whole scientific and academia landscape believe, that we need a new step. We need a leap. The techniques that we're using right now that are out there for almost 15 years, it seems they are not allowing us to get a newer level. We all know, even virtual assistants like Sophie, if you really want, you can ask an unexpected question and you can break the assistant. Well, face recognition systems are getting a lot of backlash because of the flaws and biases and everything else. Even self-driving cars, we're seeing the flaws. There's a long tail of examples and situations that everyone is trying to cover. So we need, I'm not even talking about explainability, the ability of the systems, those systems, to explain the decisions that they're taking. So there are problems, there are issues, the whole community knows that, and we are looking for this leap, this new technique, let's say, or way to build AI system that will lead us close to AGI, and hence result in better systems, in better AI solutions for us. Now, even if everyone agrees that we need a leap, naturally, everyone does not agree on how we should do that leap or what should be the technique and everything else. And then to talk a little bit about the several alternatives, I must again talk about a subject that I've been talking every time, or writing stuff, that is the two major areas that we have in AI, two major schools, let's say. We have others, don't get me wrong, and I meant no offense to the other ones, but the ones that are struggling since the beginning of AI are symbolic and connectionist schools, and because they try to approach the way we think in two different views of the world. So symbolics, they think more in a higher level. They talk about knowledge, relations, semantics, so things that are really high level, and you can't quite pinpoint in your brain, in a particular part of your brain. They are like high level functions that emerge when you have a complex stuff like our brain. Now, the connectionist folks, they are the opposite. They say, hey, no, we're going to the basic level, the structure, almost like a lot of mathematics and statistics and engineering processing signal, let's say, based on the underlying structures of the brain. And let me say that is inspired, because if I say that it's simulated, the neuroscientists will become angry at me. It's inspired on how the brain works. Now, don't get me wrong. Connectionism is on the spotlights. They are the hype. They're having a huge success on the last 10 years with the famous deep learning and deep neural network models. And it's been amazing. I mean, when you see all that we have in image and video analysis, recognition, voice, and everything, it's all due to these new models. Now, they are also reaching certain limits or having some challenges, and then the whole community now asks, well, should we think another alternative? Should we explore there? There's also, of course, people say, no, we just need more fuel here. Deep neural networks will get us there. Put more data, put more bigger models, more computational power, GPUs, maybe quantum computing. But there are other lines of thought also looking back at symbolic techniques and say, hey, let's work back with knowledge graphs, semantic graphs, and things like that. Maybe there's something to explore there, or even other crazy ideas that are more still on the philosophical, psychological field of study of the human behavior. Now, here, why I'm telling everything here in Sophie team, since the beginning, and I'm not making this up. We can see all the issues, articles that we publish, all the versions of Sophie. 7 years ago, or even before Sophie was called Sophie, when it was just a research project, uh, 10 years ago, we decided to go hybrid. We decided to not pick a side. We decided to merge different techniques from symbolics and connectionists and create this product. Well, the final result, it's really impressive. We have a tool that thinks, and we can inspect that those thoughts and everything else. I'm not saying that Sophie thinks on the level of a human being, probably not even to the level of a child, but we have this thinking model. This is what is being successful out there, and we will keep researching and keep improving that particular model. Now, I'm talking about AI as a broad field, and it is, but Sophie in particular is one in within one of the areas of AI that is natural language processing. So let me keep my journey here. We started with generic AI, and then we talked about the need of a new leap and symbolic versus connectionists. Now we're talking about natural language processing. Now, if AI was impressive, was revolutionary in the last 10 years, natural language processing in the last 2 years, it's been really mind-blowing. Uh, and if you guys are probably know, but if you're seeing everything that Google is launching, like the BERT model, or OpenAI is launching with GPT-3, you might even have read an article written, totally written by a computer, by this GPT-3 model, and it's pretty good. Now, they still have the same limitations that we're talking about. The thing can write an article, but if you ask how what's the result of 2 plus 2, it will fail, because again, um, those techniques, they are very good at finding patterns and trying to reproduce the behavior that they were presented in millions, billions of examples, but there's still the lack of thought, rational thinking, and things like that. Now, we are the Sophie product team. Why I'm mentioning all of this? The Sophie product team is uh, looking at everything that is being launched. It's looking at everything that is out of the market, and that's our primary mission, our primary goal these days. So when you have new AI algorithms and really the borders of the science on this field being expanded every single week, and I mean literally, we have new papers and studies every single week. Well, we have to stay tuned and to keep looking at everything, and we will filter that. We will bring that to our labs. If we think it's worth, we will evaluate that. More than often, we'll mix that with our techniques, because many of them are still focusing on one or another school. We are merging everything. Spencer mentioned how we are not, let's say, tied to a particular vendor, a particular technology, a particular technique. So we are free to do those experiments, let's say, and you guys will see a few of them in the presentations today. So in the presentations, you see that look at the philosophical side and study and deep thinking, but how we bring that into reality, into a product that our users can use. We don't want to research just by research. So whatever is out there, it must be reliable. Spencer also mentioned we're not only looking at AI. We got to package this in a way that it has all the security, privacy, compliance. Well, it must be able to handle a heavy load of users at the same time. It must be in a flexible architecture. So that's how we evaluate things. So we want to bring the newest and the greatest achievements of AI in the natural language field to our users. And I'm talking about a lot about technology, and that's my a character flaw, let's say. But don't get me wrong, it's all about the user. Why don't you do user? We'll talk a little bit about user. Well, here's the thing: we already know what the users want. They tell us every time, and they want to talk to one of these bots just like they are talking to a human. Well, that's really a high bar for us, and that's what we are aiming for, and that's how we are working hard to try to achieve. Because uh, to achieve the final goal of our users, we need to ultimately get to AGI, and I don't think that that's something that is easy achievable. I can't put that on the next release notes. Okay, AGI achieved, so have fun talking to this bot. But again, we will keep working, investigating everything that it's out there, putting our own flavor on it, and try with this approach to leave our humble contribution towards the next step, the next leap that the AI community has to take in order to have more intelligent systems, if not totally generic, hopefully way smarter than the ones we have today, and helping humanity as a whole in the next challenges. Well, I guess that was my main message today. And again, stay tuned, because you're gonna see many of the things that I described here in the other presentations with the product team, core team, satellites teams, and delivery teams as well. Hey, Alex.
Hello, Fabio. Let me shoot straight at you. When are the machines taking over the world?
Well,
you know, it's
I'll answer. Well, they've already done it. It's too late for that question.
one of the things we always do. I mean, and we have had this conversation for almost a decade now. Is exactly that. I mean, this Ray Kurzweil thing. Of when the machines will finally get smarter than us and start to run things all over. And as Fabio said, they already do run things all over. But I mean, it's still some of us humans controlling it. But we're trying to drill down in the question a little bit. How amazing it is, the evolution we have seen in natural language processing in the last 3 years, when things me and you thought were not possible suddenly became possible.
Yeah, that's on me, because I said in several events and articles 5 years ago. Well, we'll not get to the point that that natural language, you give a book to the algorithm, it will read the book and you ask questions, and it will give you reasonable answers. Well, the last achievements that we have, and again, it's all connections, it's all deep neural and different architectures of deep neural networks. Well, they achieved that in a way. Naturally, the answers are still not very deep thought answers, right? Sometimes we've applied that in Sophie. So sometimes you ask, hey, what's new about Sophie? And then the model will say version 4. So It's not a wrong answer, right? But it lacks a little bit of substance. We, a human, will say, "Hey, it's version 4 where you can do this and that and etc." So we are getting there. I guess the first step, this step that the connectionist community has achieved, is we are good enough in the perception layer. So the way we humans receive information from the world, right, in vision, in speech, in text, in all our senses, and we do a little bit of pre-processing, right, on all those systems. Well, we are very good at that level. Now the next step must be a little bit of deep thinking, and that's hard because we have no idea of what happens inside this thing. But yeah, I guess we are, with only perception we were able to achieve so many things. It's like we can already train anything that you can train a human to do reflexively, right? So drive cars is almost like that. So I guess that's the step we're in. But deep thinking to understand why you're taking the decisions for a system, why you're taking the decisions, that's the next step. I guess there are a lot of amazing and intelligent people in huge labs working on that right now. So I guess in the next 2 years we're gonna see some new techniques, completely new ways of think about AI, and we'll have great stuff coming.
Yeah, and one of the crazy things, I mean, is the timing, right? Because I mean, we as humans, we took 100,000 years to think the way we think. When it comes to the artificial intelligence, I mean, since the inception of it 50 years ago, to the point we got now, and particularly where we got the last 5 years is crazy. I mean, when we had the privilege to watch that from the first role. So I mean, and every new model, I mean, it challenges something we established that's very hard to be done, to the point that right now we know almost everything, as you said, that can be any process that can be done by a human being can now be reproduced if we have enough data to train it. Obviously, the next challenge is, can we do it with less data? Because when it comes to a child recognizing a cat, I mean, we need to show a cat just once. When it comes to those models, we still have to use truckloads of data to teach something. I mean, the final result is getting better and better. But the next step is can we make it simpler? When it comes to Sophie, I mean, can we? What are we trying to make the speed of training go higher and to make the platform more efficient? So, I promise this is my last question, then we'll
No,
open up
yeah,
for Luis.
yeah, Luis Cami. So since the beginning, we decided to go in this crazy hybrid path, and that was one of the main goals. I didn't want to go to our clients or users and say, "Hey, I have this amazing bot for you. I just need 1 million examples of questions that your users are asking." Then say, "Hey, come on, what are you talking about?" Especially now, people are collecting more data, but especially 7 years ago, no one simply had the data. But our model, since we're using this hybrid technique, a little bit of symbolic, semantic networks, a little bit of neural networks, so we are already able to achieve a high level of accuracy with one example. Now, where are we heading? And we already have a little bit of that with our own BERT flavor implementations that we call polymath. Well, we want
So
to achieve.
yesterday, because you guys didn't show me before the
Oh yeah, yeah,
presentation of
yeah, yeah,
yesterday.
yeah. No,
I'm sure it was a
we
plan,
don't
not
wanna,
show
yeah,
Alex yet.
not invite Alex to the product core meetings. So uh, we want to achieve zero training, right? that's the end goal. We want to put this thing zero training in terms of human interaction. We want to point Sophie to data sources, say, hey, go there, fetch the information, import that into your mind, and answer the users. We already have that. Yeah, we have. Are the questions that Sophie is learning by herself the same quality when we have our knowledge trainers putting the knowledge there? Not yet. So we want to go further and further on that path until in a certain day you have more and more autonomous learning, let's say unsupervised learning, embedded within the product.
Thank you, man. Great talk. And let's watch Luis. He comes up talking about the implementation of Sophie methodology and how we are working in North America.
Great.